All right, thank you. Okay, network security is in the older CCNA syllabus, right? In the older CCNA syllabus, we have 4 modules, but now it's been compressed to 3 modules, right? And at the end of it, they revamped at NSLA where they put a quite significant portion of it to network security. So you can see that's why we have 110 slides. But I think I'm not going through all of it at once because you can read it on your own. Anyhow, I try to explain important concept. I can demonstrate to you how the things that I'm showing. For examples, um, yeah, so we start with current state of cybersecurity. Yeah. So cybersecurity is very important these days because, as you know, if you have any system, any IT system, especially if it publicly accessible to the internet, uh, you must have some sort of security. If not, it will straight away be compromised, right? So when we talk about cybersecurity, IT security, this is a very known terms that we need to know. First, we have asset. Anything that valuable to your organization. For example, in your ATM, let's take this as examples. So anything that is valuable. So since we are in education, so the most important asset that we can have is student data, which is of course stored in our server, in our database, and that is what we call as a very important asset. And every IT system, every electronic system, every IT system has its own vulnerabilities, especially since the one that developing the system is human, right? So, for example, in the codes, there is no perfect codes. So, of course, any code have weaknesses in the system, which I can show you later on. Any system, for example, if we talk about a web server, right? So web server, we have very famous and commonly known web server for example, Apache, which is an open source system. So since it made up of codes, so there is a lot of vulnerability which we can be exploited by the hackers who bypass some of its security features. Yeah. And there is a threat. Threat is a potential danger to the company asset, the data or network functionality. So if your asset is accessible via the internet, it will have a greater risk, a greater threat to become to be exploited. And to avoid the risk that we talk about, we need to put in some mitigation measures. For example, we have, for example, if it web facing asset, so we can put uh, a firewall or we can put WAF to mitigate, to minimize the risk. So this is the security term that our student must know, so that we need to explain to them so that they can understand the term. And when I'm showing you the examples, we can see example of what is vulnerabilities, what in an exploit, and what is the mitigation so that they can relate more to what we are talking about. Um, so when we talk about network attacks, there is several vectors. Vectors is where the attack is being realized. So for examples, we have several vectors. So if let's say we are exploiting human weaknesses, so that is what we call as social engineering vectors. So if we are um, exploiting the weakness in the code. So we can say that we are exploiting vectors, we can exploiting what we call as malware vectors. So there is several vectors to realize the attacks. And data loss is where we say that data is one of the important assets that we can um, protect. So in terms of data loss, um, for example, you have student database. So if let's say your system has been compromised, so let's say they're able to exfiltrate your database, so they can take the student the student data. So that is what we call as a data loss, where they can show, they can either delete your database or they can take your database and sell it to the dark web. And if, let's say, if it's non-malicious, for example, if your devices has some error or there is some issue with your system and you doesn't have backup, so it will cause, also will cause a data loss. Not only because it is adversarial or malicious, it also can be caused by equipment failure. Yeah, so this is some of what we call as white hat, red hat, evaluation of hackers. This is our student can read on our own. Yeah. So now this is the very more interesting part of the slides, which is the threat actor tools. Yeah. So there is evolution of security tools. So we start with password crackers, which we call as rainbow tables. And we have packet sniffers, so that if there is any encrypted data is going over the network, so we can see the plain text of the data. So and it's evolved into more, these days is more sophisticated, which I will show you later on. So, and we also have malware. Yeah, so let's start. So when I do my lecture, right? So I avoid reading the slides. So for example, when during at this stage, or when we say about current state of cyber security, right? So I'm always telling my students to open up this website. So can all of you see the website here that I'm showing you, which is called Talos Intelligence? Can you see the slide? Sorry, can you see the website that I'm opening? Or do you want me
Yes.
to? Yeah. So in any vendors, security vendors, right? For example, Cisco, and we have Fortinet, and we have what? Palo Alto. Um, at their company, right? They have a dedicated team for the cybersecurity. So the team where in Cisco term, where they call it as a Talos. So where the team is dedicated to try to find a vulnerability in the system. And once they find the vulnerability, they will first try to what they call as report it as a CVE, vulnerabilities, so that the original vendors, for example, if the Talos find vulnerabilities in the Microsoft, so they will put a CVE so that the Microsoft know that they have some vulnerabilities in their system. So based on that vulnerability, they can do a patch. They can create a patch for what that particular vulnerabilities. And Cisco, Talos is one of the team that do it. And here at Talos, anyone that using their solution, for example, if they buy NetGen's firewall, if they use their spam or email gateway here. So Talos do some data collection. For example, here we can see the state of current cybersecurity. Here they just show you what is the spam. For example, if one of their customer receives a spam, right? So they will identify the source. So we can hear now in real, not I think near real time. So here we can see that for spam, a lot of it been, for example, here from this host name. Yeah. Sorry, this is legitimate. You can open up on your own, Talos Intelligence, and explore this. So here, let's see, we take it somewhere around Asia. So we have a spam here, and they can provide you with the information, more information. For example, in this host name, yeah, so it will provide to you which one, more information about this. So when we do it, so this time when I work, right? So if let's say in the last time, because um, before this, we doesn't have Gmail. Most of the organization is not using Gmail. They are using their own SAP gateway. Usually we use Microsoft Outlook server, Exchange server, right? So sometimes the problem is when we try, our organization try to send email to another organization, sometimes it will be treated as spam. Because why? Because maybe some of the user in your organization already been compromised, and someone is using their email to send a spam or to send a malicious email via their network. So here we can check. For example, here, let's say we check uitm.edu.my. So we can know the reputation of our domain in our IP. Here it will show that all the IP under UITM which has been recorded to send email. So now we can see the volume is not too much because of course, most of the organization these days already migrated their email services to Gmail, to Google. So basically your SMTP, your your MX, your email punya gateway itu already been outsourced to Gmail. But in the past, the volume will be high because if let's say your ITM is running their own exchange email, exchange server, so the server itself will send the email. So we can see that a lot of volume going on. A lot of volume is high. So sometimes when there is a lot of spam originated from your network, you will have non-variable reputation. So we always use this. So for example, is sometimes the customer complain that their email always go into the spam inbox of their destination network. So we can check this whether it is variable or not, and we can also check all the IPs which is under this organization. So this is very how we can know, even we can know the trend, email spam and trends here. We can know, for example, uh, let's say top sender by IP. We can see that currently a lot of this IP is sending in emails, maybe because of the spam. We can here see who is a network owner, which is CenturyLink, which is a tier 1 network. And in Palos, not only we can check the reputation of our network of IP or domain, we can also check for file SHA-256. What is it? So because besides checking for spam or for email, malicious email, Palos also have what they call as a threat signature. Because when you are selling security devices such as firewall, it always has a signature to make sure that you can detect latest malware signature. Yeah? So for example, we can see, let's say our server already been compromised, right? So let's say our web server is already compromised and they have some backdoor file that they put in our website so that they can later on access to our server, for example. So for example, it's a malware. So we can use, see, find a malware hashes. I always find from this malware bazaar database, it has a lot of signature which people uploaded. When they find vulnerable devices, they will share. So that these hashes can be propagated and be included in many of the firewall rules. So for example, if you are open source, you can use Snort. Snort is an open source firewall. So we can update our signature based on this hash. But for Cisco Talos, they have their own team, which is Talos team, do the checking. So for example here, the most important, the most famous malware out there is Mirai. Mirai is a botnet DOS, botnet where they will compromise the devices and they will become dormant. And later on, the hackers can use your devices to send a DOS attack. For example, here we see Mirai. Yeah? So Mirai, there is a lot of variants. So let's see. A lot of, I think should be a lot of, yeah, a lot of hashes, right? So let's say we found one from, yeah, if this is uploaded by security infocom. So let's say we take the hashes here. So let's simulate where you find this the file and you calculate the hashes of the file. Then you can try to find the file reputation in Talos. If If let's say in Talos, it is already been defined, already been loaded. So that's mean if you are using Cisco devices, your your firewall that you buy from Cisco is already have this signature. So if they later on some of your devices already been compromised with Mirai, they will able to block the traffic of this malware. Because you see, already the shark kind of already know about this. See, you know, Mirai, several alliances of that. So we can see. So this is how we treat a malware in Talos. Any question? Anything? Did I go too fast? So, okay, everyone. Okay. I hope that. Um, yeah, so this is how we can to know the current state of network security. So I'm always showing to my students so that they can explore how basically we do threat intelligence. All right, and also we have vulnerability reports. Talos team also have, like I said, mentioned earlier, that they do their own they try to find vulnerability in the system, and if they found, they will try to report it as CVE. So here, Talos, this is Talos ID, and this is CVE number. CVE number is global, yeah, because it's a global repository for network vulnerabilities. So here, this is one that Talos found. The team is found. So far, they only able to disclose 96. And other team, Google team, we have what? Fortinet team, they have their own team try to find these vulnerabilities. And we also have Microsoft advisory. So this is particularly for specific for Cisco, not Cisco, Microsoft software, Microsoft system. So we have a lot, yeah. So please do use this so that we can make our student become more, you know, more relatable to what we are trying to see. So back to the tools. So here we have several tools. For example, malware, which I will show you later on how we can do the malware. I will show you how basically we can create a malware so that we can do a backdoor. So for malware, you can read on your own. So basically, malware is a malicious code to do malicious things. And we have viruses, we have Trojan horses. We can ask our student to read on their own. And we have a common network attacks, which we have several type of attacks. So usually when you want to do an attack, right, we will always start with reconnaissance attack. Reconnaissance is where you try to find more information about your targeted network. You need to find its network IP range, what type of OS they are running, what type of services they are running. So I will show you later on how we can do it, reconnaissance attack. Then after we have this knowledge, we can do what we call as access attack. So from the reconnaissance attack, once we know type of operating system, type of version of software they are running, then we can try to find the CVEs. Like I mentioned earlier, CVEs is where somebody disclose the vulnerability of the system. So if the vendors is late, is unable to patch the system, somebody already do the exploit to the vulnerabilities. Okay, so that we can do access attack. So access attack is where you exploit the vulnerability so that you can go into the system. And if you unable, if you have other vectors where you can use DOS attack. DOS attack is very popular, since if the system you are unable to get access to it, you can make the system unavailable by sending a lot of traffic to the system to overwhelm the system. Yeah, so that is one of the DOS attacks. So yeah, so always in my lectures, instead of reading the slides, I'm always, this our student can, do it, or they can read it on your own. Even now we have ChatGPT, right? So always make it relatable by showing them examples. So here, this is how I'm doing my example. So here we have social engineering attacks where we um, we are, instead of exploiting the weakness of the software of the system, of the digital system, here we are exploiting the human itself, the weaknesses of human. Because at the end of the day, the system is, even it is digital, it is being operated by humans. So humans have their own weaknesses. So we have a set of tools that we can do social engineering attacks. So yeah, so for the lab, so let's do some examples. So let's start with reconnaissance attacks. So can so everyone still following me? Still okay? I hope okay. Yeah. So during my class, I can create my virtual machine inside a virtual box so that the student can do it. So since this is online classes, um, and I want everyone to access, so I upload the VM to AWS. I mean, I do it at AWS. Later on, we will explore more about AWS, no worries. So anyhow, let's first do some reconnaissance attack, yeah? So I have, let's say we have one web, so hold on, let me sign my AWS account. Any question you can ask me, yeah? And later on, you can do it on your own. Okay, so let's say we have two systems here. So we have one system which is web server, very secure. Later on, when I show you that we can get a password to the system, that we can do a backdoor attack, then you can know why we need to have multi-factor authentication. Because getting a password these days is very it's difficult actually. So that's why we need to have multi-factor authentication. So anyhow, so let me try to open up to start my instances. Instances is basically VM in AWS. So let's wait it for to open up. Okay. Uh, let's wait for the, yeah. So I think the SQL, yeah. Okay, so I have one web server. So this is a simple one that I do for Hansa demo, which is vulnerable. Vulnerable. So anyhow, it is running several services. Yeah. So let's say we are attackers. Yeah. So first we need to do recognition. We need to do recognition. Yeah. How we can find the vulnerabilities of the system. So we have IP address and we have the ports. So and I have another VM, let's see. So this is what we call as attacker VM. So I think already, let's try to enter our, okay, I'm using putty here to access my attacker VM. And I'm using RSA for our, later on I will show you why we need to do RSA in our module for team. So yeah, already up. So let me log in into my attacker's machine. Okay, so we have IP here. So we can do normal whois and whatnot to know more about our system. So usually when we want to do recognition attack, right? So we use a tools. So we have very many tools, Nessus, VAS, and whatnot. I'm using just a simple tool, which is Nmap. Nmap is where it will try to scan the IP to know what is the port, what is the version they are running. So we have an IP here, 13.223.9. So let's first do recognition. So I think I have the command here somewhere. Yeah, this one. Yeah. So I'm trying to scan this IP. So basically, what it do is it will try to find the operating the ports, the system, and also the operating system of the server. So let's do the scanning. So this is what we do reconnaissance attack. So when it do, if your system doesn't have a firewall or up to date, latest firewall or some um, security measures, the reconnaissance attack will become successful. So here we know that it's is it too dia kecil sangat or do you want me to make it bigger? Bigger? Just need I think
If you
16, okay.
can, the font, yeah.
Yeah, okay.
Yeah.
Again. Okay, so I put the IP and it do a simple scanning. So if you have a WAF, phone is small, yeah. Is it now okay, Dr. Mala? Dr. Malati? Or want to make it bigger?
Okay, sir. Now better.
Right,
Yeah,
thank
it's
you.
okay.
Okay, so if we do it, it will send a lot of TCP packet, UDP packet. So if we have WAF, basically our WAF or our firewall we block because they have this signature as scanning attack. So we need to use other tools. So since I'm just, I doesn't have any firewall. So here we can see that our reconnaissance attack is successful. So now we can know that at this IP is running these services. So it has at port 21, which is FTP, services FTP, and it's running on VSTPD 234. So it's running of FTP server, running this version. And we also has SSH running at port 22. And we also have web server running Nginx version 1 to yes, I will share it later on. So 1 to 2.28.0. So no, we know this is the vulnerability, this is the system. But now we need to find the vulnerabilities. So so we can try the threat can exploit the vulnerability of the system. So now we try to find in CVE. So we have CVE database. I mean, always use the CVE metric. So we can straight away just find VSTPD 2.3.4. So here, see, it's already been reported. So there is a backdoor, there is some vulnerabilities, and people will weaponize these vulnerabilities to make the exploit. So we have several CVE here. So now we know that. So maybe I can try to see whether we can exploit this. So now we know we have CVE. So when you do ethical hacking, we have what we call as Metasploit. Metasploit is a framework where a community where they will share exploit to certain vulnerabilities. So here I try to exploit this FTPD server. So I'm using Metasploit. So to open it, I'm using MSF console. Yeah, so this is a Metasploit. I think latest one. I saw the latest one, which is 6. Oh, by the way, all of the tool you can obtain from Kali Linux actually. So Kali Linux is if you are learning about cybersecurity, every student know about Kali Linux. So anyhow, let's try to find for VSTPD. Yeah, so it said that yeah, basically it has vulnerability for VSTPD, right? Like shown here. So let's try to exploit it. So we try to exploit. Let's use number 1. If I'm going too fast, you can stop me. Yeah, but this is not cybersecurity class. This is just I'm showing to you so that the student examples to the students. Yeah, so that they can know okay what is malware, we can exploit and whatnot. So now that yeah, so we want to exploit. So let's see the option. So I think the most important one is the R host. R host is what we call as the target host. So the target host is I think the server IP is 13.239. Okay. This is the target host. And what else? Nothing more. So I basically it's only our host. So let's try to exploit whether this is, yeah. So now we can do it able to exploit the vulnerabilities. Yeah. So now we can obtain we can access the shell of the server. So now if I'm using, so now I have a shell access to the server. So now if I use the command hostname, I think. So this is the hostname of the target server. So if let's say I want to know more, if I want to confirm, let's say I use this command, addr. So I think this is the internal IP of the AWS server. And if I want to know more whether this is really the correct one, so let's try go to home. Yeah, I think, yeah. So this is really the system. Yeah. So now we can basically have shell access. So if let's say you want to deface the website, so you can go to their web server root and you can change the index to HTML or index PHP so that you can change with their. So this is, this is typical how we exploit the server. Yeah. Any question? So this is we are exploiting for the FTPD services using an exploit based on CVE. Question? Okay. Think, yeah.
Yeah,
So this is
one question.
yeah.
Uh, so can we know the login ID and password using this one?
Yeah. So let's say usually in Linux we can I think this is root. But if you want to know user which is available in this server, usually in the slash home. So any user they will have their own user. So here we see that we have FTP and Ubuntu hostname
Folder.
folder. So that means there is a username for FTP and username for Ubuntu. But in terms of password, it's quite tricky a bit because usually the password is not in the older Debian or older Linux. It's shared. It been shared in the what we call as a plain text. But nowadays dia dah tak ada lah. Basically even here in the password D is not stored in plain text. But we have other things, and doesn't mean that we have a password. We can have the SSH password. So actually, when we able to get the shell, what we can do is we create our own username. Let's say we
Okay.
want to have a backdoor, right? So attacker will create their own username and password so that they can access later on. There is one thing, and we can also put a backdoor, which I can show you later on, which we use what we call as reverse TCP shell. Is that answer your question?
Okay, but for example, that website just now,
Hmm.
if somebody key in his username or password, this
Okay.
backdoor can record that
Okay, for example,
character.
yeah, okay. Maybe this is there is another vector, right? So this is what this is we are using vulnerabilities in the FTPD service. So okay, so I'm showing you another vectors, which is the web vectors. So okay, so we have done with the what we call as vulnerabilities in the FTPD punya FTP punya service kan. But now we have another thing which is we have running a web services. So now we can use a web vectors. So here we have NGIX. So of course because hacker know, alright, so this is the system. So now they can use another vectors, a lot of vectors, and what we call as always as WAPs. Okay. So one of the most common vectors is what we call as SQL injection lah, if you doesn't have any input sanitization. Okay, so you can try to do it. Okay, I will share to you the URL here at the chat box so that we see whether we can do some SQL injection. So how to go to chat. Okay, so everyone can open these vectors. Sorry, vectors website ni dan try buat SQL injection. So I will share to you this command. So the most common way kalau kita nak try sama ada dia buat input sanitization atau tak, we can use this is common one because when you use this, let's say if they doesn't use any framework, for example like Laravel or whatnot. So kalau Laravel dia MVC, dia buat model view controller kan. So that's mean the input before the query kat database dia jadikan dia model, the template. That's mean what we call as a parameter quantization. So it's a prepared statement. So that's mean you are not direct based on this, you are not directly querying the database. It first understand your input, then it will create some model of your query. So this means there is a prepared statement. So anyhow, that is for MVC. So without that, this is normal PHP MySQL punya tu kan. So here, kalau orang use select from something. So here, if we use this, we will try to close first the first statement. Then after that, we use or one. So in here, this is main true in SQL. Then after that, this is the comment. The comment that means anything after that we just comment. The real query that we want to do. So if you use this anything, so that means we're able to bypass. So now we can dump all the we can access all the data in user in the MySQL database here. So this is a very simple one, and we have another more. So everyone can access this. I open in AWS and I share with you this one. So you can try to play around first. I give you 2 minutes. Let me put in chat box and you can play around. And maybe you can ask ChatGPT or Gemini to explain to you about all of these SQL query. And maybe we can discuss later on. Okay, anyone can open this website? Try to play around. Okay. Anything you can ask. Dan berbalik kepada soalan Dr. I think Dr. Faris kan tanya tadi. Dr. Faris kan yang tanya tadi pasal password tu kan. Kalau orang kita boleh buat SQL injection yang for this one, kita basically boleh tahu password user tu. Kalau dia tak share See betul? Kalau dalam database tu dia tak kalau orang tak, that's mean kita tak encrypt, kita buat dia dalam plain text. That's why it's very bad idea to save password in database in plain text. You need to basically hash and salting so that you are not storing in a database the plain text password, but basically you are storing the password of a user hash.
Okay.
Itulah mungkin menjawab soalan ke doktor?
Jap.
Boleh
Cuma
try, play around.
saya tak boleh masuk this 13.212.161 public IP this one kan.
Tak boleh dia belakang ada port 8080 tak boleh
Boleh, tapi bila nak login,
Okey. Maksudnya bila doktor nak send kat sini dia apa ni kan? Dia tak boleh, maksudnya kalau doktor buat macam ni, dia macam hang kan?
yes,
Doktor daripada universiti mana?
ATM.
Doktor UiTM punya firewall, kalau doktor sekarang dekat dalam bilik kalau guna UiTM punya network, kita ada firewall tau, firewall dekat kita punya gateway tu. Kita guna Palo Alto. So ini common lah, SQL injection ni dia akan block. Kalau doktor nak try,
Okay.
doktor try buka wifi, guna hotspot, disable wifi UiTM tu, masuk pakai 4G ke 5G mesti boleh. UiTM dia ada
Okay.
ada firewall. User sendiri tak boleh. So pasal student kita banyak buat SQL injection. Mungkin kita ajar cyber security kat kelas kan. So dia orang selalu nak try deface website internal kita. So ada firewall. So try
Baru
doktor try
dah
boleh.
keluar.
Keluar
Okay,
boleh
dah
kan?
boleh.
Pasal UiTM ada firewall. So at least kita tahulah. Kita spend juta-juta untuk firewall tu kira jalan lah.
Worth it dah.
Hmm.
Okay.
Okay, anyone ada question lain? Anything? Data ada work, betul. Pasal kita kalau guna kampus kita ada firewall. Student kita selalu buat
Attack.
apa ni? SQL injection ni.
Because you teach them.
Sorry?
Because you teach them too.
No lah, bukan. This is common. Pasal
Kawan.
dulu kan ingat lagi. Zaman saya student. Time tu tahun 2010 lah. Saya ingat lagi Encik Hamid dekat saya fakulti tu. Shah Alam. Saya dulu student Shah Alam. So they teach us SQL injection, all this metasploit. Habis semua server UiTM tu kita go down ni kita dapat masuk. So now kita dah lah. Okay, so can we go to another things? Maybe I can demo to you. So puas main SQL injection ni. Okay, so let's go to another vectors. Okay, now, so ni SQL injection lah. So this is very low level exploit. Basically, it has evolved into more what we call as more advanced lah. And we have what we call as SQL Ninja and everything, so that we can have more sophisticated punya SQL punya injection punya ni. Okay, thank you Dr. Ahmad. So working right? Okay. Please play around. I am start the VM instances. Okay, so now we have another vulnerabilities, which is what else? SSH. I think I can, but I will show you another one, which is backdoor malware. So here I'm going to show to you another way that, for example, we can use social engineering. Social engineering is another human vectors. Instead of we relying on the code vulnerabilities, so we can do social engineering lah. Human punya weaknesses. So kita akan send spam email and whatnot. We use this. So I have prepared this one VM, which is running this social engineering tools. Let's see. And this is also you can play around, yeah. Let me hopefully okay. Okay, all right. So ini yang buatkan kita rasa macam pentingnya multi-factor authentication kan. This one I will show you. Let's okay. Let's take example as Dr. Lucy. Let's say Dr. Lucy is currently Timbalan Net Chancellor Infrastructure at UiTM, Digital Chief Officer. We take example, kan? So, wow. So we can, let's say we want to exploit dia punya human punya weaknesses. So let's try to find LinkedIn. For example lah, ni lah, usually what people always do. So we open up LinkedIn. Let's try and find. Dr. Lucy, do you have any LinkedIn?
I do have, but I don't have much post inside it.
Just oh, maybe
One
if
white
we
only.
can,
No, never mind,
how
never
we can
mind.
find
Just
your
find
email?
me. Never mind, just
There,
find
Lucy
me.
Anti, Lucy.
Yeah, one YANTIE. TIE.
Ada.
Yeah, that's me.
That's you. So did you share your email here? Must be, right? Tak ada. Oh, tak ada, okay.
I'm secure.
Let's say I try to PM you at LinkedIn, right? So I have your email. Eventually, I have your email. So what I can do is I can craft you a phishing email. So I say that, Dr. Lucy, currently you are under integrity issue. So please log in to your HR2U to update your apa ni, your asset declaration, for example. So what we can do is the attackers, when they have your email, so they can, let's say they open your ATM stuff. Okay, so they find that, okay, the staff have this website. So let's say they know that, okay, HR2U. So this is where, so I can put in the phishing email. So I can say that, please log in here so that you can update your, what we call is your HR2U for harta, right? So here we can do is we can clone this website so that it can make it somehow like resemblance to this. So we clone this using these set tools. Okay, okay. So I have this, I think set tools. Let's first I see. This is too small, right? Okay, so again, okay, set2 is basically a Python script, basically. So anyhow, okay. Right, so I'm using this tool so that I can fool Dr. Lucy, for example. So I'm using social engineering attack. So let's say using website vectors. So I'm using credential harvesting. So I'll use a site cloner. So this is the IP address that I need to put so that I can receive your password. So basically this IP address of my VM lah. So here I have this address. Okay, and I want to clone this website. I know the HR2U, so let's try and clone this one. Okay, I'm cloning. Okay, so now I will put in the email about the declaration harta tu using this website. So here I'm, okay, now nampak tak ada clone? Somehow almost the same, kan? And I can make it more realistic by registering my domain. Let's say I'm using hr2u.uitms. I can use the hr2u.com.my, for example. Sometimes people will not, they takkan perasan pun. They will not, if they're not looking closely, that and we can also register with SSL and everything. Yeah. So for example, you can play around. I put it in the chat box. Don't put, jangan letak yang betul lah. Try letak, cuba login tu. ID and kata laluan. Put anything of you guys punya credential. So let's say I'm putting Azizi 123. Right? So nampak, it will redirect to the real website so that maybe Dr. Lucy cakap, so mungkin ada error first time kan, so dia redirect. Tapi actually, if we see here, I can basically already get your your password here. Lucy 123, you see? So this is what we call as credential harvesting. Azizi 123. Who else test? Boleh test lah, siapa nak test, Abu. So now we can harvest. So that, did you guys notice that UITM here for HR2U, they doesn't have multi-factor authentication. So that's mean if you have username and password, that's mean you can already access the staff portal, right? So is that safe? So that's why we need to have multi-factor authentication. Even though we nowadays we should assume that people already have your email and your password. So that's why we need to have multi-factor authentication. Do you get the concept? So that's why we need, this is where we exploit in terms of human weaknesses. So this is what we call as website punya vectors. Okay, so now, so I think enough, so I can stop and return. So, and yeah, so that's how we do credential harvesting. Any question, guys? Okay. Okay, right? Okay. Now that is, we go back to a slide. So there is social engineering. Yes, yes, very. There is downloadable. So if here, Dr. Lucy, I'm installing at my VM. I'm installing it piecemeal. Basically, I go to GitHub and there is a set punya repository so I can download. But if you want to have all in one to do this penetration testing, you can just download Kali Linux or VM distribution where it has all of these tools pre-installed. So can you use on your own lah. Nama dia Kali Linux, right? So now let me show you about the backdoor or malware punya vectors pula lah. So for backdoor, let's see here. Okay, so for backdoor, what else do I have? Okay, so we have social engineering. So I think I can shut down the instances. This one is also can shut down. Okay, so now I have another VM which I want to demonstrate to you that we can do backdoor attacks. So let's say you have already access to the system. Either you are using vulnerabilities on the software itself by finding out the CVE, or you try to exploit the web vulnerability. For example, they are running web server, so you are using SQL injection, cross-site scripting and whatnot, or you are trying to enter the system via the human vectors using social engineering, like I'm showing earlier. You get the username and password, right? Now, at the end of the day, you have access to the system. But most of the attackers, they doesn't only want to access the system. Now, the real damage is done when you already access the system. You want what we call as maintain your session. That means you can later on access back to the system so that you can maybe go what we call as lateral movement. You can, from that system, you can go to another system with higher privilege, or you can use that system as a jumping point to attack another system. So at the end of the day, in order for us to do that, to have a further exfiltration, we need to maintain access to the system. So that's why we can use a backdoor. We need to use a backdoor, mostly using a malware. Either you are using that, or you can have another way. Let's say I'm showing to you. So here I have a victim VM. So let's try to start instances. Oh, by the way, do you guys need a break, or can we start with the demonstration, or do you want a break? Okay. Kita teruskan lah ya. Okay, so I have a victim VM here. Okay, so okay, I think okay. So that means, let's say you are this system admin, right? So the attackers already gain access, or they want to they want to create a backdoor to this server, for example, and this server is running on Linux. Later on, I will show you how we can use the same backdoor for Android. So now, in order for us to have backdoor access to this server, we can craft a malware. So using the Metasploit framework as well. So let me enter my any question can ask me, yeah, in case if there is something that I'm too fast or you doesn't understand. So I'm trying to crafting a backdoor. So I think yeah, I'm using. So here is I'm using Metasploit punya framework, and I want the payload to become a Linux reverse TCP, which is a malware, basically a malware, to make a reverse TCP shell. And the host here is my attacker's IP lah. So that means that the malware the malware will send back the backdoor information to the attacker's host. So this is the IP, and the port is 444. And let's say instead of I'm simply put it as backdoor to ELF, which is quite suspicious. Let's say we use as nama yang lebih okay lah. So let's say we use PDF, and let's say we use student. Let's say kan kita nak tipu orang, so we use student.pdf. So we create a file. This is a malware file. So now we have student.pdf. So this is a malware file. So now that we have the malware, we need to make sure that the malware is at the server, either using social engineering, or you are exploiting the vulnerability in the code. Anyhow, you want to execute the malware at the server, or you can ask the people, you can send the file via email, and when the people double click the system, the file, it will execute the malware. So now, let's assume that I'm already able to compromise the system. So now I want to upload the malware to the server. Okay. So let's say first I'm downloading the malware first from my Metasploit. Okay, so student.pdf, right? So try to send. Seems like a normal, if you if you notice, seems like normal PDF, right? But if we double click, this is malware. So even if you are using Windows Defender, right? Basically, it will detect as malware. So I think because let's if we scan, I think they will find. So anyhow, let me try to upload first to the victim VM. See, it found as a backdoor linux, right? So since we're going to allow this, so anyhow, this is a malware because of course somebody already upload the hashes to the database, and as the Windows Security Defenders database already pick up that hashes as a signature. Okay. So anyhow, let's try to upload the PDF into the. All right. So already uploaded. Okay. So now in the victim, we already transfer. So here we have the document.pdf lah, right, inside our server. Okay, so now we need to execute this, right? Either asking the victim to double click, or anything that you can do. So we need to make it executable. So let's see, student.pdf. Okay, and at attacker side, we need to create a reverse shell punya, so that we can receive back the information of the backdoor. So I think we need to use, yeah, multi-handler. Then we can use reverse TCP as a payload. Then the host is this. Here. And run. So it will listen to port 444 at this IP, so that it can receive the backdoor data that sending from the victim when they execute the malware. So you guys okay? Still can follow? Okay. Okay. So I'm executing the student PDF. So now you see we have received a reverse shell. So using here, now I can take control of the server. So let's see. I want to system info. So now I'm able to access the victim machine. And let's say I want to, what else? Get a shell. So shell, so now I'm in the shell. So now I'm in the server punya shell lah. So that means I can deface a website, I can do anything. I can install Mirai botnet so that I attack another system. So now I am taking control of the system. Okay. So who am I? So maybe if I can see the system architectures. So now we are taking control of the server. So this is how basically once the attacker has a backdoor and has access to your system, they can install a backdoor. In more sophisticated backdoor attacks, usually backdoor is using specific port traffic. But if you want to make it more stealthy, you can actually leverage on DNS traffic. So you can there is a new type of malware where you can put in your traffic inside a DNS traffic, so that you can you have a backdoor session on top of DNS traffic. It is more advanced now. So this is the basic one if you want to use a backdoor. Any question? So this is we are using malware punya vectors. Any question about backdoor using malware? No? Okay. Right. So now I'm going to tell you, maybe before we take our break, we can, last thing, like maybe I can show to you a malware on Android. So this is more personal because most of people nowadays are using Android, right? So on my Metasploit, I can create another payload. This is for Android. And for Android, I'm simulating using BlueStack. So BlueStack is like a virtual box, but for Android. Oh, hold on. Let me. So let's try to create an APK file with backdoor. So the host is okay. So let's say we treat the user as game APK. So we try to create this payload. So now it's just a matter of you can send an SMS or you can send an email, and they can open via they can open at their Android devices. When they click on the APK and they install at their Android, and I can show to you that we can control their Android devices. Yeah. So for example, here we have the APK. So let's try first download APK. You guys must be asking why every time I need to open the public certificate, why I not just save it first time, right? Because I'm using AWS. AWS, I'm using the free tiers. So I'm using a floating IP address. That's mean every time I restart or I shut down my AWS instance, I will get different IP address because I doesn't want to pay extra for the static IP address. So that's why. So now this is the APK, right? So I'm downloading here at my PC. And now I need to just install it. So now this is Android, yeah? So this is Android. So I'm going to sideload an APK here, installing the app. So now if I'm just click, so now that's mean here, oh, sorry, I haven't do the reverse punya, punya receiver for the payload. Let me, Okay, so I think we have set the handler. Wait a minute. Okay. So now, let's try to take this. Right. So we have opened a session here. So now we can take control of the Android devices. So here, let's say we want to find the location. We we want to keep track on the location of the Android devices. So yeah, start again. Okay, so let's try again. Okay. Okay, so now I think we have already a session, right? So we have start a reverse TCP. Um, reverse TCP. This means we already have backdoor into Android. So let's see what the command that we can use. Yeah, so here we can dump a contact SMS, but of course I'm using the BlueStack, right? So BlueStack is they doesn't have SMS or call module. But anyhow, let's say we want to find a location. So geolocate. We want to know where is the location, right? So let's say here we can simulate a location inside the BlueStack, I think. So let's set a location here. Okay, I'm setting the location. So now, if we run back the geolocation now, we have the location of the phone. So we can keep track where is the phone is. Or maybe more scary stuff where we can get a screenshot. Or we can maybe record a camera. So let's say webcam snap. Oh, I think because I didn't check. Is there a webcam here? Oh, I'm sorry, because Webpack is using my webcam and BlueStack is basically using my webcam, right? So let's say I'm trying to shut down my camera, right? So let's try again whether can stack access camera. Okay, long. Okay, I think okay, good. Let's try again. Hopefully, still. But I did try, can basically. For example, I try to show you here that I did write it last time. Example here. So we have covered social engineering. What else? DOS, I think I cannot show to you, but anyhow, it's you are try sending overwhelming traffic. You can use TCP sync and whatnot so that you can overwhelm the system.
Okay, thank you very much, Dr. Azizi. It's very
All
nice.
right. Thank you. So we take a break for a minute, yeah? Okay. Okay, can we continue with our lecture? A bit, just a bit more, about network security. Everyone ready? All right, so let me share slides. Okay, so I have demonstrated to you how we can use different vectors, and also the vulnerability. We can also exploit the vulnerability of the IP itself, because the IP protocol has many of its vulnerabilities. For example, here we have ICMP attacks, amplification, man-in-the-middle attacks, because ICMP by default didn't encrypt its payload, right? So that's why we can use a man-in-the-middle attacks. So we can change the destination IP and whatnot. And from the ICMP and amplification attack, we can use it to do denial of service attacks. And this is how students can read at their own. Most important thing is we need to provide the example so that they can, relate it back, and they can later on when they read it for their exam, they can know, okay, this is example that my lecturers are showing me. And also we have attack which exploit on the vulnerability of the TCP and UDP itself. The most common one is where we exploit the vulnerability in the TCP session establishment, where we can use it to make what we call as TCP sync attack. Is some kind of DOS attacks where we can overwhelm the server by sending many bogus TCP attacks to exploit the TCP handshake process. Yeah. Also, vulnerability of the IP services from ARP, cache poisoning, DNS attack, DNS tunneling. This is one what I'm telling you earlier, where to make our backdoor more stealthy, we can try to hide our backdoor traffic inside a DNS traffic, so that many of the firewall is not really checking on the DNS requests. So our backdoor has high chance to get through to the firewall if we are using DNS tunneling. Yeah, so now we have learned about all the attacks that we can use on the system or the network. So what is the network best practices? So of course, any system must has this CIA, confidentiality, integrity, and availability. We must able to ensure that our data have this requirement. And to have that, we have what we call as defense in depth approach, where we have multi-layered devices, VPN, firewall, IPS, AAA service server, to make sure that every step of our network must be secured. For gateway, we have firewall. For our web services, we have web application firewall. So for our user authentication, we can use AAA servers such as for example, we can use Kerberos or we can use Radius, so that we can verify user identity. So this is firewall, IPS, and most of these security devices, in order for them to deliver this CIA, data confidentiality, integrity, and availability, is depending on cryptography. Cryptography is what we call as cornerstone of any what we call as IT security system, digital security. Cryptography means that we are hiding the plain text, the plain data, into hidden text, which is only known by parties which has the key. So that is what cryptography. So by having the cryptography, we can deliver these four elements to secure the communication. Data integrity, we can sure that the data has not been changed while it's in transit over the network. Yeah, so we can use algorithms such as hashing, MD5, SHA-1, or we can also guarantee origin of authentication, where we can make sure that that the data is received from a valid parties. So we can use digital signatures, and we can ensure data confidentiality by encrypting the data, the payload, by using either symmetric or asymmetric encryption. And we also can ensure data non-repudiation, where the sender cannot repudiate that they are the one that sending the data. So modern encryption algorithm must able to deliver these elements. So data integrity is where we can use a hash function. So basically, in your PC, you have your in what we call as a checksum, basically a built-in hash generator. So for example, yeah, here I have a file here, game, right? So we want to create a SHA file so that we can know that when we sending the data over the network, the receiver can calculate back the hash so that we can match the hash so that we can know that nothing is changed. And also, we can use it as a signature. Like I mentioned earlier, we can use the signature to report to the malware database so that we found this file as malicious. So how we can use it? So if you have your laptop, in Windows 11, for example, Windows 10, we have a command prompt. And basically, Windows has built-in hash generator. So basically, if I'm not mistaken, is the software, sorry, the prompt is hash util. I think so, hash util. Yeah. Sorry, cert util. So this is the command, yeah, cert util hash file, and this is the file that you trying to create a hash. So here, I'm putting my file here at the desktop, right? So any one of you can open your command prompt and go to your document or your desktop and try to generate a hash. Yeah. So here I'm going to desktop. So CD desktop. Yeah. So here I have my file game APK. So using this, I'm trying to find a hash for my game APK. Game.apk, and I'm using, so we have SHA-128-256, but in modern system, most of it are using SHA-256. Even if we want to upload our SHA here at the one at a malware database, here we need to upload our SHA-256. Most of it is a SHA-256. So this is the SHA. And this is by right is unique because in hashing algorithm, it's not should not have collision. Collision is where we have two different files, but we have the same hash value. By right, it is only unique. It can create a unique hash value for this file. If we done some modification to the file, the SHA will change. Any question? Did you guys able to generate a SHA using your window?
I'm using Mac.
Or using Mac? Ada juga tak silap. Mac dia guna
Kat terminal
Mac
kat
ni.
terminal lah.
Kita tak bercakap, kita window-nya. Tak, dekat Mac tak silap saya dia ada pakai apa ni RSA apa? SSL tu, Open SSL nya tu. Tapi
Sikit,
tu kena install sikit lah.
Okay.
So ini untuk window lah.
Jomlah
But
Dr. Fahmi, kita pergi buat group lain.
Buat group. Group
Mac
Mac.
users buat group lain.
but just one question. Little bit off from this topic. Not a bit off. Bitcoin pun using the same function and untuk generate to complete the transaction between two parties kan. The hash,
Betul. Dia
tapi
basically mathematical tu dia pakai hashing lah, betul.
Ah,
Dan
tapi
sebenarnya
just
apa yang kita try nak mining tu, dia nak try do all the
automatic.
calculation so that dia dapat hash tu.
So
Dapat hash, dia dapat balik hash yang sama. Silip saya lah.
so that's why we need a good GPU to do calculation. Is it? I mean
Good,
for
okay.
mining, right?
For mining, dia lebih kepada mathematical punya tu. Dia kenapa dia nak why they need a GPU, or basically not just a GPU. Even kalau mining rig tu, dia kenapa dia nak pakai ASIC chip tu, asal dia nak parallel. That's mean dia nak buat all the calculation tu in a parallelized manner lah. So dia memang dia punya hardware tu, as of course GPU dia ada thousand of cores kan. That's why GPU kenapa, or even dalam machine learning pun we are using GPU kan. But anyhow, it has ability to do parallel processing. Itu Dr.
So
Lucy dah
basically,
share.
basically doing the same thing lah kan?
Yes, yeah.
Okay, okay.
So here we are using the hash. So this is a cornerstone of what we call as modern punya communication lah. So later on, I will share to you. Let's say if let's say we open uitm.edu.my, right? This is actually many things is going on at the back. So here, if you open uitm.edu.my, if you open here in connection is secure, here we can see that the even our certificates that the certificate is changed, we can use they are using the SHA-256 to track a hash, so that the certificate that we receive from the CA is tally with what we have, what is in their database. So the hash must be tally. So this is, they are using the hashes. Yeah. So anyhow, this is for data integrity. And we have many hash function, MD5 and SHA and SHA-2. And basically MD5 is already been outdated, is already been phased out, because MD5 is not what we call as secure, because many of the papers, academic papers, especially in cryptography, already prove a theorem or show a proof that basically they can break a MD5 punya hashing. That means they can able to get the same hash with different file. So that's why MD5 is not secure anymore. So that's why they are moving using SHA and variant of SHA lah, SHA-256, 384. And this is origin of authentication, where we use the hash so that we hash the digital certificate, so that we can know that it come from the correct parties. Yeah. And for data confidentiality, so basically we are encrypting the traffic from the data from the plain text to the encrypted text. So we have two ways. So we have symmetrical and we have asymmetrical. So for symmetrical, where for sender and receiver, this will use the same key. This means you only have one key. Okay, but for asymmetrical, for sender, you are encrypting the traffic, you are encrypting the data using a private key. Then the receiver will decrypt the data using your public key. So this means there are two sides of key. So for asymmetrical, one single key, asymmetrical, two keys. But there is a difference. In symmetrical, the process is less computational heavy, less computational extensive, and more faster. But for asymmetrical, it is more what we call as computationally costly. So that's why in modern architecture, we are using both. So let me show you as a demonstration. You can do it on your own, yeah? So you can open your browser. Here I'm using Chrome. So to make it tally, you can also open up Chrome at your PC. So open your website, let's say your university website. Here I'm using UITM, right? So at UITM, you can click here, and when you see here, connection is secure, right? So what happened is, there is many things is going on back here. So when is asymmetric encryption is used, when is asymmetrical process is used. Okay, so when you open this website, the first thing that happens if you are using HTTPS, HTTPS is basically HTTP over TLS. So by using TLS standard, the first thing that is being done is there is a key exchange. That means between the server and client, before they can create a secure session, they need to exchange a secret, basically a shared key, which is used for symmetric encryption. But in order for them to do it, they will use what we call as asymmetric encryption. There is a public and private key. So that asymmetric is used in order for you to encrypt the symmetric key. So maybe I can do something here. So let's say we have here a server. Sorry. So we have a server. So here we have client, which is your browser. So first, client will send a hello. So this is what I am telling you about TLS. Yeah. So TLS. So for TLS, client will first send a hello, right? So server will reply back with their digital certificates. EC, digital certificates. And digital certificate is based on RSA. Basically, basically the server will send it digital certificate so that we can verify that we are talking to the right server. So it is using RSA, asymmetric encryption. Yeah. So that's mean the first thing that I'm doing is first my browser trying to verify that I am talking to the right UITM, because nowadays people can spoof, right? So that's why we have a digital certificate. So here it send me with digital certificate, which is uitm.edu.my, and this public certificate must be signed by the what we call as CA. Certificate punya CA is what? Sorry. Somehow someone is verifying the public public certificate. Yeah. So here we can see that uitm.edu.my sent its public certificate to the CA, and CA must verify that the domain really been verified by UIT, is really belongs to UITM. And for example, yeah, certificate got thank you, Dr. Lucy, I forget. So here in Malaysia, we have several local CA. So one of it is post digital, yeah. One of it. And let's say if we see their services where they offer their certificate, and there is a three level of trust. So three level of way that they can verify. The most basic one is DV, is just a domain verification, the base level. And this is most of SSL certificates, because they only take several minutes, and they only verify your domain based on your domain. Because when we want to CA to verify our domain, we have what we call as CRS, CSR file, where there we have our IP address, domain, and we ask the CA to sign. Yeah. So this is the very fast, very if we are using a hosting services, most of it is using this level of sign. But if we have a better level of verification. So we have what we call as OV and EV. EV is extended validation. OV, I'm not sure, but most this is more what we call as there is more process, because here instead of just verifying our domain, they will ask for us for example, our organization registration, SSM and everything. And they will ask for, they will try to call, they will ask for us for number, and the CA will call us to make sure that we are really the person that having a domain, and the highest level of trust is EV, a standard, where why it take 3 or 4 days. Basically, they will send their officer to our organization, and they will see that whether the building is really is the whether the 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 address that we send to CA in the CSR is really valid. So that's why here, I think in UITM, we are just using domain validation. So that means they only validate our IP address and domain. But for bank, for example, if you are using CIMB clicks here, let's see, I'm trying open CIMB clicks here. So if we open up, you can do it on your own. If you see the connection is secure, try to see their certification. So here we can see that global sign, see, extended validation. That means the bank, based on the PCI DSS punya standard, which is Finance Bank Negara punya regulatory punya framework lah. Basically, they must, for banking institution, they must use extended validation for their website. So this is more expensive and more time consuming. So EV. So so that's why not all digital certificate is the same. So UiTM basically they just buat domain validation lah. So I'm not sure your IIUM. Let's see. Let's find IIUM. What type of certification that they use? IIUM is better. It's using OFI. So that means the certificate is trying to what we call is it has a medium tier punya tu lah. That means the CA need to have all the organization registration information. They will do a phone call to the CDO so that they can verify the domain before they can sign the certificates. Any question? Boleh But anyhow, this is first the process lah. So basically, kita make sure that we are talking to the right server using PKI lah. Okay, and this is based on RSA punya public and private key. Then after that, both of a server and client will exchange their what we call as session, not session. They will use DeFi helmet. DeFi helmet, DeFi helmet is another asymmetric encryption, so that they can have what we call they have a public and private key. Public and private key. Okay, they had a public and private key just for that particular session. Okay, they had a public and private key. And using the public and private key, they will have another. They will change a secret, which is the session key. Session key is asymmetric key. So nampak tak? Dia guna RSA. Yeah, that is for the certificate. Then they use DeFi helmet. Then they will assert a secret key where they will use asymmetric encryption. Once they establish the session, all the data will be encrypted using AES. Usually AES lah. 128. So there are the combination. So that's mean when we open up our website, secure website, a lot of going on. From the certificate verification to the session, they nak establish key exchange for this session key. Then when they have session key, they will use symmetric encryption. Sorry, symmetry. So asymmetric, symmetric. Okay, why we use symmetric once we have established a session? Because symmetric is fast. So when you already have a shared key, so you can use asymmetric, AES. But if you want to exchange the key itself, the key though, it must be used public and private key. So they must be using asymmetric, which is they are using DeFi helmet. Not RSA, they will use DeFi helmet based on the shared secret. So how do you want to confirm this? If you open up your browser, right? If let's say I'm using Chrome. So if you are using Chrome, you can use F12, F12. and it will open developer punya, it will show developer punya console lah here at the right. So here we can see that here we are using TLS 1.2. So using TLS, nama lama dia adalah SSL. The older name is SSL, but when it's been standardized by ITF, it named TLS. That is TLS version 1.2. And for key exchange, it using asymmetric, namanya elliptical ECDH, which is elliptical Diffie-Hellman. E is ephemeral. This means ephemeral, every time you establish a session, they will create their public and private key. So the public and private key is not the same for every time the HTTP session. And once with RSA, this means nampak tak ada RSA di sini. RSA is where when you want to verify the digital certificates. And once you have the exchange the session key, when you have the session established, the when you have a shared secret, then the encryption of data is using AES 256. You see? So a lot, dia campur. It's not one solution fit all. They will mix and match so that they can have better modern security. Any question? Kenapa Diffie-Hellman tu dia guna anyone selalunya saya tanya student lah, kalau student tu selalunya dia akan tanya, kenapa dia tak guna Diffie-Hellman biasa? Why use elliptical and ephemeral? Any question tak? Anything that you want to ask about modern punya encryption standard? Okay, so Diffie-Hellman, so you go back here ya. So ni symmetrical lah. So for symmetric, like say same key so we have 3 dash. Modern standard we are using AES. Modern standard, most of TLS is using AES. Even if you are using SSH, is using AES. We have another one which is reverse cipher, which is quite good also, very fast. And RC is used in more for application which is need a very fast punya encryption lah. Usually we use it for VPN. Some VPN is using RC. And now this is asymmetric encryption. So for asymmetric, we have public and private key. So here we have Diffie-Hellman, but Diffie-Hellman, this is not like I said, for key exchange we are using Diffie-Hellman, right? So for Diffie-Hellman, it is very good for exchanging key, but it is very computational expensive. They are very computational expensive. So some people are using what we call as elliptical curve punya technique, EC. So that it can make the elliptical tool with using smaller key. So nampak tak? Key length kat sini is very large. Here is 160, but have the same security as Diffie-Hellman. So that's why the elliptical curve. But ephemeral tu apa? So here we have ephemeral, right? Ephemeral mode in, that means in the Diffie-Hellman, ephemeral code, ephemeral tu, that means every time the session is being established, we will create new public and private key. Why? Because we want what we call as PFS, perfect forward secrecy. Because if we are using the same public and private key, each time that we are every time we are establishing the SSH session, without PFS, if the hackers able to get your private key, that means all your past communication will be what we call unsecure. That means bila one day they have your private key, they can decrypt back all your past secret, past data. So we doesn't want that. That's why we have what we call as ephemeral. Every time we have a private and public key. Understand? So that's why we use Diffie-Hellman, because Diffie-Hellman is one of algorithm of asymmetric encryption that can provide PFS. Okay, perfect forward secrecy. Yes. So you can read on your own. So that's all for network security. Any question? So this is model standard lah. And kadang-kadang ada student tanya tau, one my student lah, quite a brilliant student. Dia tanya kan, okay, kalau kita punya certificate macam UiTM, macam CA tu yang CA will verify, will sign our certificate, right? So siapa yang akan sign CA punya certificate? Any ideas? So one answer is they have a key signing ceremony. You can open to YouTube. Basically, it tried to sign a self-signed certificates. So, for example, DNSX key signing ceremony, where so this is the ceremony lah. So basically, they have you can see every time the key is expired, the root key expired, they have a ceremony where they will have a auditable public punya ceremony so that they can self-sign their own root certificates. So that is what root key signing ceremony is all about. Okay. Okay, so that's about it about network security. Any question before we go to another module, to next module? Question? Yeah. Okay. Not been changed.